All right, starting with the hardest stuff first. We're going to graph some reciprocal trig functions. So this was not on your previous final, so it is going to be on this final, but it's the very first week of the semester. So let's see what we remember. Now, I've got a couple numbers here that I'm going to have to take into account, but really it's the secant that is really going to, I'm going to have to pay attention to that and figure out, remember what that means. So secant, if you remember, is related but not equal to cosine. Okay, those are the two that are kind of connected to each other. One is the reciprocal of the other. Okay, so what we want to do then is we want to graph cosine as he normally would be, but because I'm taking his reciprocal, I have to look for all the places where he is 0 and then have an asymptote there, because I cannot actually have a division by 0 take place. All right, so let's graph cosine as he normally would be at 3 here for an amplitude and then 2 for a period. Okay, now that's not the period, but it's related to the period. So let's see if we remember. We know we're going to go up to 3. We're going to be 3 high. Okay. But we are, because that's the amplitude, but the 2 means that I need to have the period equals 2 pi over b. And you just have to remember that. So you'll notice then that if I put a 2 here, because that's 2, okay, that's your b in trig functions, then it looks like we got a period of pi, which means that cosine is going to finish his cycle in 0 to pi units. Okay? So, looks like then we go from 3 all the way to 3 again. Okay? And then in the middle is where he went all the way to -3. Remember, trig functions should always have a nice, beautiful symmetry to them. Now I'm going to graph these, but that's not secant. Okay? I'm going to keep going. Okay? So I'm just going to now just estimate that this guy probably looks like this. No, he definitely looks like this. It's not an estimate. Okay. All right. So this is going to help us graph the secant part. Okay. So here I'm ready to commit to the secant part. Wherever cosine is 0, that means that secant would have been a 1 over 0 once I flip it. So therefore, I'm going to put an asymptote at every instance where this guy is 0. So it's 0 there, 0 here, and 0 here, and 0 here, and his would be 0 right here as well, and right here. Okay. All right. Now all this is basically saying those asymptotes is everywhere where secant cannot be. Okay. So because this guy is at the top of his hump here, we know that we could just have a parabola just kind of floating right there above it. Here will be one that is floating below it. Okay, so just go to the top of the hills every time. Okay, they're strange looking, but this is the graph of all the trig functions except cotangent. Cotangent looks almost identical to tangent, but he's just flipped around. All right. And to those of you paying attention to the video, just know that there's not going to be cotangent on the test. Okay. Now here's cosecant. This guy's going to be related to sine. Okay. So I shouldn't put equals. I'll just put like they're related to each other. Okay. Now this guy has a 2 for an amplitude, but then it has a 1/2 theta. Okay. That means then that when I figure out my period, it'll be 2 pi over 1/2, which actually equals 4 pi. So this means from 0 to 4 pi, sine will complete his cycle. So we're going to go 0 to 4 pi. Okay, and then right in the middle is another 0. And then going this way as well, we would have another 0. So everything should be nice and symmetrical. And what happens in the middle is that we go to its highest maximum value. That highest maximum value would be at 2. All right, and just remember that we are graphing what it is not. Okay, this is just a guide. These are guideposts for us to figure out what the cosecant one looks like. And of course, wherever it equals 0, that is where we're going to have the asymptotes. Okay. All right, they're weird looking, but remember, if you know how to graph cosine and sine, then these guys are actually not that hard. Okay. All right. Now, what I did do over here is I did take it for granted that you guys remember that cosine starts at the top and then ends at the top. Over here with sine, we're going to start at 0 and then end at 0. Okay. And then this guy will, I don't even have to draw sine. I can just take this top part here and draw the parabola springing off that upwards. This guy will spring downwards, and this guy will spring upwards. And that's pretty much a little better. It's got to go up to the asymptote. In fact, it should actually squeeze a little closer, but that's okay. I'm not going to nitpick that. Okay, as long as you got the general outline. In fact, sometimes I'm just counting how many curves you have, and then that'll let me know that you know what you're doing. Okay? All right.